Okay, let's look at question 3 here. Remember, the PDF for these exercises is in the description below. Okay, a criminal has just robbed a bank and gets on their motorcycle to escape. Their escape route is along a straight and level road, and for the first 4 seconds of the motorcycle's ride, the velocity is given as Vx equals 0.750 meters per second to the 4th power, t cubed. What is the motorcycle's acceleration when v equals 10 meters per second? Okay, so what are we looking for? If I identify what our goal is, let's look at that. First, our goal is to find here our acceleration when the velocity is 10 meters per second. Okay, so that's what we want to know. We want to know what is our acceleration at some time t naught, and this time we're going to sort of say is when the velocity at this time is equal to 10 meters per second. So I'm just sort of translating the question into an equation form, into math. This is what we need to know. When this condition is true at this t naught, what is our acceleration going to be? Okay, so we have to figure out sort of this time at this velocity here. So our first step then is probably going to be to find t naught, right? What time is this going to be? So we're going to use our velocity equation here, and we're going to say, well, our velocity at t naught is equal to 0.750 meters per second cubed times t naught to the 3rd power, and our condition is that it is equal to 10 meters per second. So now we can just solve for t. Okay, so let's do that. Let's solve for t here. So t naught cubed is going to be equal to 10 meters per second over 0.750 meters per second to the 4th power. And what we could do then is cube root both sides, and this will allow us to get rid of this. Get rid of this here, and that is going to solve now for t naught. So let's plug in some numbers here and see what we get. All right, so we get 10 divided by 0.75. It gives us this number here. We want to take the cube root. Unfortunately, my calculator here does not have a cube root function. So, does it? No. Okay, so I'm going to use the exponent. Remember, a cube root is the same as x to the power of 1/3. Okay, so I'm going to take this and I'm going to raise it to the power of 1/3. That's the same as taking the cube root. So I get here 2.37 seconds. So that's the time when we want to find our acceleration. Okay, so let's find the acceleration now. So now we're going to, step 2, find the acceleration at this time. Okay, so what's that going to be? Well, in order to do this, we need to have an equation for our instantaneous acceleration. We don't have that yet, but we can get it because this is going to be equal to the derivative of our velocity equation. Okay, so let's take the derivative of this velocity equation, and that'll be our instantaneous acceleration equation. So that's going to be using the power rule. We're going to take this cube and we're going to bring it down to the front there, right? So that's going to be 3 times 0.750 meters per second to the 4th power, and then t to the power of 3 minus 1. As we simplify this, we're going to get, what is this, 2.25, right? It's going to be 2.25 meters per second to the 4th power, t squared. Okay, so this is our equation for our acceleration. And now we want to solve for t naught. And t naught in this case is 2.37 seconds. So at this time, what is the acceleration? Remember, that is our final goal here. That's what we want to find. So At this time, we're going to have 2.25 meters per second to the fourth power, and yeah, 2.37 seconds squared. So we just plug in some numbers there. So here's that the number of seconds. Let's square it, and then we'll multiply it by 2.25. 2.25, 12.7. 12.7 meters per second squared. And that is going to be our final answer here for the acceleration when the velocity is 10 meters per second. Great, hope that helped out.